Okay, now, you might have noticed already, this was 0 triangles possible. Okay, when it's less than the height. This is 1 triangle possible. We're kind of counting up. Okay, so guess what the next case is going to be? It's going to be 2 triangles possible. Okay, now this one takes some explanation. So let me clear out the page again. Oops, cleared out the wrong page. Okay, again, we're still given A is 30, so that's still in this corner. B is 6. Okay, let me move the yellow height out of the way. Okay, what if we said A was now 4 instead of 3? Notice it's still less than that top side, and now it's bigger than the height. Okay, so it's somewhere between the length of this side and the, excuse me, undo. Okay, it's somewhere between the length of this side and this side. Okay, so what does that mean? Well, this line here is longer than the height. Okay, if I rotate it all the way over, trying to keep the same length. Okay, it's shorter than that side, yet it's longer than the height. Okay, so that means, let me make sure it's back at the same length. Okay, that we could have a triangle, okay, formed there. Okay, or if I rotate this around, I could have a triangle there. Okay, so I've already cloned it and flipped it over. Okay, so now I could have 2 triangles possible. Okay, now what I'm going to do is go back to single page to make this bigger. Okay, there's my 2 triangles possible. Let me move this stuff out of the way. Throw this guy over here. Okay. Our 2 triangles that are possible, I'm going to outline it and then move it. Here's one. Okay, not perfectly overlapping, but gets the point across. Or here's 2. I'll do this one in green. Okay, notice one is most definitely an obtuse triangle and the other one an acute triangle. Now, there's 2 triangles possible. Let me switch their order, because this is the order I suggest you solve them. Figure out the acute triangle first. Again, the 3 given are going to remain the same. That angle there is going to be A. This top side is going to be B, equal to 6. And now we're also given, in this case, A equal to 4, which was longer than the height, but shorter than that top side. This triangle over here, same thing, because these are given, they're true in both triangles. Now, the 3 things we're going to have to find are going to be angle B, angle C, and side C. Now, since there's 2 triangles possible, if I put B here, this one would also have to be B. They're clearly 2 different angles. So we're going to have to label with subscripts B1, B2. Same thing with angle C. Okay, this angle is different than this angle. So I'm going to call this one 1, this one 2. And again, I'm labeling them in the order I suggest you solve them. Figure out triangle 1 first, and then the obtuse triangle second. There are reasons for this, which I'll get to later. That makes this side little c1, and this side little c2. Okay, so we have to find not just 3 parts, but 6 parts, because they're going to change depending on which triangle you're looking at. So there's 2 triangles possible, so we have to solve for both triangles. Okay, and again, we're going to solve the acute triangle first, and then the obtuse triangle. Now, I left those 2 red lines up in the original setup for a reason. Okay, if we look at this triangle, what's special about it? Well, we said both of these sides are representing A, and A doesn't change in the problem because it's a given. Go back up to my given. Okay, it's a given. So it has to be the same in both. Okay, so they're both 4. So what do we call a triangle with 2 sides congruent? Isosceles. Okay, what's special about an isosceles triangle? Well, it has 2 congruent sides. And you might remember from geometry, the Musubi theorem, SSA Case description, where if 2 sides of a triangle are congruent, then the 2 base angles are congruent. Okay, call this the Musubi theorem because the base angles looks like a Musubi. All right. What the heck does that have to do with anything? Well, let me clear out the highlights. Okay. That means, remember, we labeled this one B2. Oops, excuse me, B1 in that triangle below. Okay, these angles are the same. Okay, in the second triangle, B2 is technically here, but it's this angle inside here. Well, from that Musubi theorem, we know this angle has to be congruent to this angle. And what's the relationship between B2 and then if this is B1? Well, they're supplementary angles. So that means B2 will always equal the supplement of B1. And that's a nice thing because we don't have to use law of sines to figure out B2. Once we figure out B1 when we solve the first triangle, we'll know B2 by subtracting from 180. Okay, so that's an important thing to remember. Okay. Now in both cases, once we figure out B1, okay, let's, for example, if we're staying in triangle 1, once I figure out B1, now I'll know A, B1, and then I can calculate C1 because the sum of the 3 angles has to equal 180 degrees. So I can subtract the 2 angles we know from 180 and get the third remaining angle. So now we have B1 by law of sines, C1 from subtracting from 180, and then we can calculate side C1 by using law of sines. Okay, then we're done with triangle 1. Now we'd have to do triangle 2. Well, we already said B2 we're going to calculate by going 180 minus B1. Notice again, once we get B2, we know 2 out of the 3 angles, so we can calculate C2 by subtracting the sum of A and B2 from 180 to get C2. Once we have that, we can use law of sines one more time to figure out side C2. So in reality, at most, we're using law of sines 3 times. Okay, we're going to use law of sines to figure out B1 and C1, and then we're going to use law of sines to figure out C2. Okay, so going back to our cases. Okay, this was a pretty bad case because we had to figure out 2 triangles, we had to find 6 things. It wasn't that bad, okay, because we're only using law of sines 3 times. But this is the summary. So if your other given side, that's the top one, is greater than your side opposite the given angle, and that's greater than the height, 2 triangles possible. Okay, that's why I made all this stuff in red. Okay, this is the worst one. You're going to have to stop and slow down and do some work. Okay, now we'll do a full example afterwards. Again, I'm just showing you the setup right now. Okay, hopefully you don't have questions. If you do, hit the rewind, go back, look at it again. Again, when we do the example, it hopefully will make things a little clearer. Okay, so that's 3 cases. I told you there's 4 cases. Okay, so let's go back to this page, clear it up. Okay, let's move the isosceles parts out. Okay, so we did where side opposite the given angle was 2, that was less than the height. That was good, no triangle possible. Okay. Then we did number 3, side opposite the given angle was equal to 3, which was equal to the height. Okay, 1 triangle possible, and it's a right triangle. Semi-good case. Then we just finished 4, where that's bigger than the height, but less than this top side. Okay, then there's 2 triangles possible. Okay, got to stop and slow down and do a little bit more work. Okay, notice all 3 of those cases again were less than this other given side. Okay, so we could do the same thing with 5, but it's still going to be bigger than the height, still going to be less than this, so it's going to be 2 triangles possible.